Okay, let's unpack this. Imagine a company where the CEO isn't a person in a fancy suit, but an AI. Sounds like something straight out of a sci-fi movie.
Yeah, it really does.
Well, that's precisely what we're diving into today. Because get this isn't just some futuristic fantasy. It's a fundamental shift happening right now in boardrooms around the world. We're moving from AI as a mere assistant to AI actually making the big decisions.
It's true. And what's really striking here, I think, is that this isn't merely a technological leap. It's more profound. It's a fundamental paradigm shift in corporate governance. We're sort of hurtling towards a world where algorithms don't just inform, but actively control decision-making.
Wow.
Which immediately raises crucial questions, right? Like, how do we even define law itself in this context? And how do we make sure these AI-driven decisions actually align with human values and, the legal frameworks we already have?
I can see the critical importance of that point.
Mm-hmm.
It's a massive challenge and, honestly, one that impacts all of us. Our mission today is to cut through the complexity. We want to extract the most important nuggets of knowledge from this deep dive into Anna Romanova's fundamentals of modeling algorithmic decisions in corporate management. It's from 2024.
Right.
This research explores the profound implications of AI taking on these high-level management roles. And it really highlights the urgent need for something entirely new. Algorithmic law will help you understand not just what's happening, but why it matters for our collective future.
Exactly.
So let's jump right into the surprising reality. AI is already in management.
Yeah, it's not theoretical.
No.
Yeah.
And this isn't just about AI supporting human directors anymore. These systems are actually controlling decision-making processes, holding real power. It's a complete transformation in how we think about corporate leadership.
Definitely.
For instance, you might be surprised to hear about Mika, a humanoid robot who serves as the CEO of the Polish company Decoding.
A humanoid CEO, yeah.
Or Alicia T. She's a top manager at the Swedish company Tieto. And in Hong Kong, Deep Knowledge Ventures uses AI systems named Vital and Spock in management roles.
Vital and Spock, okay.
Even Aiden Insight is a non-voting board observer at IHC in Abu Dhabi. So these aren't just digital assistants, they're embedded in the leadership structure. I wonder if Mika gets a corner office. Or maybe just needs a charging station more than a window view.
Yeah, probably less water cooler talk either way.
Right.
But this presents a core challenge for us, doesn't it? The inherent difference between how we as humans make decisions and how AI does it.
How so?
Well, human decisions are these incredibly complex social constructs, right? They're influenced by a whole tangled web of things: organizational rules, procedural norms, cultural contexts, and of course our own skills and biases.
Makes sense.
AI decisions, though, they're technical constructions, very precise instructions, ultimately based on, binary rules. Zeros and ones.
Okay, that really drives home the urgency. But how practical is it to bridge that gap, between human social constructs and AI's technical constructions in a real-world boardroom? Policies designed for human directors aren't always applicable, or maybe even possible, for an AI system. It forces us to reconsider the very nature of decision-making itself, especially when it comes to corporate governance.
It's a fundamental question. And what's fascinating here, actually, is that this idea of codifying decision-making isn't entirely new. We can trace a historical quest for what we might call algorithmic law, this concept of reducing law to a set of algorithms that computers could automatically execute.
Really? Going back how far?
Centuries, actually. If we connect this to the bigger picture, some great thinkers were essentially foreseeing the need for what we now call algorithmic legislation. They understood the potential, but simply lacked the technical and societal tools to realize it back then.
That's fascinating. So who were these historical figures imagining such a future?
Well, take Gottfried Leibniz, for example. Way back, he argued that if a question in a law were correctly understood, there would always be a single correct legal answer. He actually views law as a computation. He even envisioned resolving disputes with mathematical precision, almost like two accountants sitting down to calculate the truth.
Like crunching the numbers on justice.
Kind of. And then there's Pierre Laplace. He saw probability theory as common sense reduced to calculus. He predicted that mathematical calculations could surpass human reasoning, which sounds very much like what we expect from AI today.
That's truly incredible foresight. Leibniz and Laplace were certainly ahead of their time. But, one might argue that reducing law to pure computation risks losing the very human element of justice. No. How do we balance that?
That's the crux of the issue now, yeah.
And as you said, their visions weren't fully realized then, mainly because the technology simply didn't exist.
Yeah.
Yet now, with AI developing so rapidly, the source argues that high-quality computational law is the most important condition for the successful development of modern human civilization.
A pretty strong statement.
It is, especially given the potential dangers of technological singularity, that hypothetical future where AI surpasses human intelligence, leading to, well, unpredictable, rapid societal change.
Precisely. And what's interesting is that parts of our legal system already operate somewhat computationally. It's not entirely alien.
Like what?
Think about existing tax law.
Yep.
Individual rules are often represented as mathematical functions, right?
Mhm.
And they apparently don't require a huge amount of legal interpretation.
Ah, okay. I see that. So it shows that it's not entirely foreign territory for us.
Exactly.
So why is this algorithmic legislation such a big deal right now? What's the urgency?
Well, it comes down to a very real problem we're seeing unfold as we speak. When natural language laws, the laws written by humans for humans are translated into code for AI, compromises are inevitably made.
Compromises. How so?
Because normal languages, code, simply can't capture all the nuances, the ambiguities, the sort of implicit understandings packed into natural language.
Yeah.
This can lead to an erosion of legal procedures.
The danger here, and it's a serious one, is that many normative decisions about what should be done are currently being made by engineers inside a black box. There's no explicit legal regulation, no real public agreement. It's like a counterfeit product in terms of social legitimacy.
A counterfeit product.
Yeah.
That's a strong analogy. And it feels like we've definitely seen the real-world consequences of these ill-defined AI policies already.
Oh, absolutely.
I'm thinking about the Amazon recruiting system failure. Remember that?
Yeah, that was a big one.
It was designed to automate hiring, but it quickly showed a significant gender bias against women. It was basically penalizing resumes that included terms like women's chess club.
Right, learning from past biased data.
Exactly. And leaders lost hope in the project, and it was ultimately dissolved. This just perfectly illustrates the importance of legitimacy, doesn't it?
It really does.
The more power a firm or an AI system has, the more its exercise of that power must be perceived as legitimate. Without that legitimacy, people will find ways to resist, maybe even through the law itself.
Or just by refusing to use the technology.
True. So if we need this new kind of law, this algorithmic law, what's the first step? Where do we start?
Well, the source proposes a pretty concrete solution. A reference book, or maybe think of it as a dictionary, for formulating the algorithmic foundations of management decisions.
Okay, a dictionary. What would that look like?
So for you, the listener, this basically means we need a clear, shared language for AI. A dictionary that lets everyone involved know exactly what an AI means when it makes a decision. This allows for informed consent or, informed disagreement.
I see. So everyone's on the same page, human or machine.
Exactly. This reference book would enable what the source calls a dual formulation of management decision foundations. One version in ordinary language for human decisions, and another in an algorithmic or mathematical version for AI decisions.
Like two parallel tracks.
Precisely. This dual approach is key to allowing mixed boards of directors, composed of both humans and AI, to work effectively together. It ensures everyone understands the precise meaning of terms and decisions. Essentially, we're creating a common language, a Rosetta Stone, for humans and AI to operate within corporate governance.
Okay, that makes a lot of sense. But this brings up another layer of complexity, doesn't it?
How so?
Well, we often talk about corporate decisions needing to be things like fair or competitive or transparent. For us humans, we have an intuitive grasp of these concepts, even if we argue about them.
Sure.
But for an AI, you can't just say, be fair. You have to define how to calculate fairness, and maybe even define within what numerical boundaries it remains fair.
That's exactly right.
How do we even begin to define such abstract concepts for an algorithm? It feels like we're moving from philosophy straight into mathematics.
We are, in many ways. And this is where we need to introduce fundamental mathematical principles into algorithmic legislation. It's unavoidable. The law of large numbers, for instance.
Yes.
It basically tells us that the more data or measurements you have, the closer your results will be to the underlying probability, the expectation.
Okay, and why is that crucial here?
Because it introduces ambiguity into AI decisions. Intrinsic ambiguity. Unlike a human decision, which we often perceive as singular, like yes or no, AI decisions built on probabilities inherently have a range of possible outcomes.
Range.
Yes. And the powerful thing is we can actually observe and control that ambiguity, which is something new.
So the core insight here isn't just that AI is different, but that it forces us to fundamentally rethink certainty itself, moving from black and white guarantees to shades of probability.
Precisely.
That's a huge shift in our legal and ethical frameworks, isn't it?
It truly is. To illustrate, consider the Enron email example mentioned in the source. When using a specific type of AI, a random forest classifier, to identify suspicious emails from the massive Enron dataset, they ran it 200 times. The results range from finding 8,633 suspicious emails to finding 15,120.
Wow, that's a big range.
It is. The average was 11,277. But the key point is the outcome isn't a single fixed number. It's a distribution, a range.
And the implication?
The implication is profound. For autonomous AI systems, something as fundamental as the right to life and dignity might in the future be guaranteed only with a certain, even if very high probability.
Unsettling.
It is. And this shift from seeking 100% guarantees to accepting probabilistic guarantees needs to be announced, explained, and agreed upon in advance. It's effectively a new kind of societal contract we need to negotiate.
That's a mind-bending shift in how we think about fundamental rights.
Okay.
So the law of large numbers helps us understand the range of AI decisions.
Yeah.
But how do these systems actually learn to make those predictions from mountains of data in the first place?
Well, that's where other mathematical tools come in, like the central limit theorems. They're foundational for machine learning. They essentially allow the AI to generalize patterns from a sample data set, the data it's trained on, to an entire population, informing those predictions about new, unseen data.
Got it. Foundational for AI learning.
Yes.
Now, this reliance on data brings up another crucial point. Defining a minimum or optimal amount of data. An AI needs to make a sound decision.
Absolutely critical.
We can't just let an AI make critical decisions if it hasn't seen enough information.
Right.
And we need rules for what happens if there isn't enough data.
Yeah, what's the fallback?
This reminds me of an interesting counterexample the source brings up. The Netherlands' policy for building dams.
Oh, yeah.
They don't just consider average sea levels. They focus on extreme values, modeling the tails of the distribution, the really unlikely but catastrophic events.
Smart. Planning for the worst case.
Exactly. It highlights that sometimes simply looking at averages isn't enough. You need to account for the outliers, especially in high-stakes situations.
That's an excellent point, and it brings us neatly to the concept of an interval, which the source argues is absolutely vital for algorithmic law.
An interval, like a range again.
Sort of, but with a specific legal implication. Think about the OECD transfer pricing guidelines for multinational companies. They acknowledge that transfer pricing is not an exact science. So there can be an interval of numbers that are all relatively equally reliable and thus legally legitimate.
Okay, so multiple price points could be considered fair market value.
Correct. For AI, we need a similar concept. We need to define when an AI can make decisions that fall within such a legitimate interval, where maybe a range of outcomes are equally acceptable, versus when it needs to calculate exact values.
And it's interesting because these mathematical statistics terms like median and interquartile range, they're actually creeping into everyday business language already.
They are.
They help clarify ambiguous terms like market price for both humans and AI. For instance, those OECD recommendations suggest using statistical tools to narrow the range, like an interquartile range. And apparently Kazakhstan law actually prescribes using the median value for certain related party transactions. So these concepts provide a clear, agreed-upon framework.
Yeah, the language is evolving.
We touched on the Enron email example earlier, talking about the range of results. How could this interval concept apply there?
Well, you could use an interval in a couple of ways. You might define an interval for the quality of the AI model itself. Say, any classifier trained with accuracy above 98% is acceptable for use.
Okay, setting a quality bar.
Right. Or you could set an interval for the output. Maybe the probability threshold for deciding if an email is suspicious needs to fall within a certain range, rather than being one fixed number. It provides flexibility within defined boundaries.
Right, defining acceptable boundaries.
Now, let's really deep dive into fairness, because this is arguably one of the most complex, abstract concepts to translate for AI.
Yeah, well, I can imagine.
As we said, humans can interpret fairness generally, intuitively, but an AI needs it pre-formulated and agreed upon to work effectively. It needs the rules up front.
Explicit instructions.
Exactly. And this need for predefined certainty becomes starkly, maybe chillingly evident when modeling extreme situations. Think about self-driving cars.
The trolley problem, essentially.
Pretty much. Programmers have to develop cost functions that assign values to different outcomes in an accident scenario, potentially determining who lives or dies based on pre-programmed rules.
That's a heavy responsibility for a programmer.
Immense. And unlike a human driver reacting in a split second, the programmer has time to deliberate. They have immense responsibility to define these life and death choices, often without clear legislative guidance.
That's a huge ethical burden and a legal gray area. And it also brings up the pervasive problem of bias in AI systems, right? Even those trained on vast amounts of data.
Absolutely. Bias is a major hurdle.
This small experiment the source mentions with Gemma 2 really hits home, doesn't it?
It does illustrate the point well.
It seems to confirm that big intuition we all have. AI, especially these large language models, will reflect the biases present in the data they're trained on.
Garbage in, garbage out, basically. Or bias in, bias out.
Right. So the Gemma 2 model generated only 3 female CEO names out of 20, just 15%, clearly reflecting societal stereotypes baked into its training data.
Yeah.
And even a simple logistic regression classifier they built, without any specific fairness policies put in place, confidently indicated that female candidates for CEO positions were not suitable.
Oof.
How do we begin to counteract that deeply embedded bias?
That's a critical question. And this is precisely where legal and moral principles must be integrated into the technical design. It can't just be about accuracy. Deborah Hellman, a legal scholar, advocates for a specific moral principle for machine learning. Avoid exacerbating previous injustice.
Avoid making things worse.
Essentially, yes. Her idea is that if an action, even one that seems neutral on the surface, would actually make an existing societal injustice even worse, then there's a strong moral reason to avoid it. It's a crucial lens for evaluating AI's impact.
That's a powerful principle. Avoid exacerbating injustice. Makes sense. And what's really striking is the sheer breadth of fairness definitions already being used in machine learning. The source mentions over 20 of them.
20? Yeah, it's not simple.
They're categorized by various factors: predicted outcomes, actual results, probabilities, similarity, even causal logic. It gets complicated fast.
Very fast.
So to give you, the listener, just a sense of this complexity, one definition is statistical parity. That might mean an AI's outcome should mirror the population demographics. So if women are, say, 49.75% of the relevant population, a fair classifier under this definition would predict positive outcomes for men and women with equal probability.
Right, equal rates of positive classification.
The initial Gemma 2 experiment, with only 15% female CEO names, clearly failed this definition of fairness. But then there's another definition like predictive parity. This might say the AI should be equally accurate in its predictions for both groups, even if that leads to different demographic outcomes overall.
So maybe it approves fewer women, but when it approves them, it's just as likely to be correct as when it approves men.
Exactly. So in another example from the source, maybe the positive predictive value, the accuracy of positive predictions was 0.8 for men, but only 0.66 for women. That would indicate a lack of fairness under this specific definition.
Right. Different definitions, different results, different potential impacts.
You can see how quickly it gets complicated. But even with just 2 examples, which definition is the right one?
And that's the core issue. Given this complexity, it's absolutely essential for companies using AI in significant ways to explicitly define which algorithmic fairness methods they choose, and crucially, to specify them in policies for shareholders, stakeholders, the public. Transparency is key.
So they have to declare their definition of fair.
Yes, because if a company doesn't legitimately specify these methods, then who is truly managing the company? Who is making these fundamental choices about fairness? It's effectively the developers and programmers inside that black box making profound decisions without oversight or public consent. That's a serious challenge to traditional corporate governance.
That's a sobering thought. Okay, so all of this complexity, all these challenges, it circles back to the proposed reference book or dictionary for algorithmic terms.
It does. It's proposed as a practical tool to manage this complexity.
And what are its vital functions again?
It basically has 3 core functions. First, a reference function. The idea is to create bilingual local policies and procedures, policies understandable by both humans and AI for collaboration in these mixed boards. It bridges those terminological gaps.
Human-readable and machine-readable.
Exactly. Second, a systematizing function. It helps companies find, discuss, and agree upon the specific mathematical or algorithmic terms they will use to model necessary social and legal constructs, like fairness or transparency.
So a structured way to have that conversation.
Right. And third, a normative function. This allows companies to actually set and change the correspondence between ordinary language terms and algorithmic terms, at least as an interim measure, until comprehensive algorithmic legislation is established by governments.
It provides a crucial interim framework while the broader laws catch up.
Precisely.
And what about the structure of this reference book? How would it be organized?
Well, a couple of options are mentioned. You could structure it based on a list of social concepts, fairness, accountability, transparency, etc. Or you could structure it based on the AI development cycle, fairness in data collection, fairness in model training, fairness in deployment metrics.
Which seems more practical.
The source suggests that since policies are usually developed for the social system first and then translated for technical systems, a structure based on social concepts probably makes the most sense initially.
Okay, start with the human concept.
Yes. And crucially, it needs to be an open type dictionary, something that can evolve and be updated as AI technology itself evolves, because this field isn't standing still.
No, definitely not.
So really, this deep dive reveals a critical truth. These algorithmic terms, they aren't just abstract concepts for machine learning theory papers. They profoundly influence the structure of our society. The shift to AI in management is here. And the translation of our social and ethical norms into technical ones is already happening, often, as we've discussed, illegitimately inside that black box of engineering.
Hidden decisions.
Yeah, and the past, embedded in the data these systems learn from, could very easily exacerbate historical injustices if we don't act decisively and thoughtfully now.
Absolutely. For autonomous AI systems to be truly legitimate, to be accepted and trusted, we need public acknowledgement of this new reality. We need that transparency. And we urgently need dedicated algorithmic legislation. It's fundamentally about ensuring our cherished values, fairness, dignity, accountability, are encoded into these systems, not eroded by them as we build this new future.
Well said. Encoded, not eroded.
So here's a final thought for you, our listener, to ponder. What responsibility do you think we have as a society to actively shape this algorithmic future? Should we be letting it be designed in the shadows by engineers and corporations, or do we need to be more involved? How will we, all of us, ensure the values we cherish are encoded, not eroded? It's a big question, and one for all of us to think about as we continue to dive deep into the future of technology and human civilization.